Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, we're going to be testing out a few random PC motherboards, well, two of them actually, and this cool video card. This has VGA analog output, that is, and digital output. I don't think those cards are very good, but we're going to see if this one works. We have a 386DX motherboard here, and we have a 286 motherboard that has SIP sockets on it. Single inline memory packages. I don't know what that stands for. Anyhow, let's see if these things work. For facilitating this, I have my little test bench here. So we have a power supply there. We have a mouse pad to insulate the motherboard. And then I have this 36SX board here. Now, I think what I'll use this for is, I know this is a working test bench here, so we'll test this video card first on this setup here. And incidentally, in case you're wondering, I have a regular floppy drive IDE controller card here that has the compact flash adapter connected to it. So this is just one of those simple CF card adapters. We have a little card here. This is a ROM card. Essentially what this has is the XT IDE ROM on here. And that's because this thing is a 36SX, so its BIOS on here does not support large hard drives. So with this installed, all this does is it sort of takes over the hard drive routines from the stock BIOS, and then it allows the large compact flash cards to work properly. And then we have a post analyzer card in here, which can be helpful if we're having issues with any of these motherboards getting them started. In addition, I have some 30-pin memory here. This is going to go on this 386 motherboard. So we'll talk about the motherboards in a moment. We'll just move this stuff off to the side along with this RAM here. First, I need to see if this thing is working. It's always good to test your capture setup first. And I'll start by using a known good 16-bit ISA VGA card. So pop that in. I've learned over the years that you can be, what's Dave Jones say? Come a gutser, I think he says. If you don't test your capture setup, because what can happen is you think everything is working, you know, with your capture setup, that is, because I'm not going to be plugging a normal monitor into this. I'm going to be plugging this into my capture setup here so you can all see what I'm doing. And I can think it's all working, and yet I'm like, oh, it's broken, it's not working. So that's, it's good to test with known good stuff first, especially with things like Commodore 64s. I know that's not always possible if you don't have a bunch of extra Commodore 64s, but plenty of times I've had my capture setup has let me down where there's a black screen, but it's actually coming from the capture setup and not the 64. So using a good 64 hooked up to, you know, the capture setup plus the power supply, just make sure everything is working properly. I get the good, you know, basic blue screen, and then I know I'm ready to go with one that I think is faulty. That way I'm not getting any, well, I'm not getting the impression that there's a problem with the machine when the reality is it's just a problem with my capture setup. So the VGA connector here is going into my capture device, and I look at that, we're not getting anything here. I think I'm on the wrong HDMI input, so I'm just switching there with my little switch box. And let's see here. Okay, there we go. So that's my Extron. What model is this? It's an RGB HDMI 300A. That's what I used for capture for VGA. It's got a little menu there. This thing doesn't have a keyboard connected, but I have it hooked up to power. So let's turn this on. If I can find the power switch, here it is. And let's see if we have video. We do indeed. Okay, excellent. Now shift it over a little bit. I just went and grabbed the keyboard here. That is just an issue with the capture setup. So I'm going to go into the BIOS here. Let's Control-Delete again. And this will give us a full screen. Oh, it looks absolutely horrible. Let's go auto image. See if that helps. Okay, well, at least it's mostly centered, but the lines you're seeing there, again, this has to do with this DSLogic card. I think it just doesn't play well with this particular capture device. Just for fun, I hooked this setup up here to a VGA monitor I have here. It's an LCD screen, and it looks absolutely perfect. It's centered, no lines. So yeah, I guess whatever, there was a slight incompatibility with that capture device. Now I found that is the case sometimes. Some VGA capture devices and certain ISA cards, especially the older video cards, just don't always play well together. And I'm not actually sure what causes that little bit of weird interference. I'm gonna plug the capture device back in. Yeah, it just, it doesn't look great, does it? Let's see about switching modes. Oh wait, there we go, okay. So, this is a little confusing, but the Extron 300A has, well, one of the issues with it is not really designed for DOS mode capture. And DOS VGA actually runs at 720 by 400 at 70 Hertz. But there are actually two different modes that run at 70 Hertz that come out of VGA cards. One is the text mode, 720 by 400, and the other is a 640 by 400. And that is used for the 320 by 200 graphics mode. So 320 by 200 on VGA, it's actually scan doubled both directions. So it's really running at 640 by 400, and it's running at 70 Hertz. So not 60 Hertz like EGA and CGA, even though they're running at the same pixel resolution, well, 320 by 200, VGA actually amps it up to 70. The thing about the Extron capture device is it can't really tell the difference between the text mode 720 by 400 and the graphics mode at 640 by 400. I think most LCD monitors can, you know, they kind of like do a little bit of testing and synchronization when you first input a video signal to them, so that they're able to tell the difference and you get proper rendering of all the pixels and stuff and it doesn't look messed up. The Extron, on the other hand, it can't really tell the difference, at least not automatically. Now, if we go into menu here and I pick auto image, let's see what happens. Okay, it's, well, there's those lines again. Well, what I've done is I actually went ahead and I hooked up the serial connection from the Extron. This is like a box that has, you know, the video inputs, video output on it, and then it has a serial control. I think this thing was designed originally to be used in, for instance, like a office conference room hooked up to a projector, and so people could plug in various video inputs into it. So it was designed with serial control in mind. Now it does have these menus here. So if we go to input configuration, this here is how you set up the 720 by 400. Now, actually, I don't know why the active pixels here is not 720. I guess it doesn't really matter. But one of the things about the Extron, which is kind of annoying, is you notice here it has these user presets right here. Well, it allows you mainly to set up things like the color balance and stuff like that. You cannot save any of this input configuration stuff. So all of this stuff, which has the, well, the digitizer that's in this box, the only way to actually create profiles for that is using the serial port. And you read the manual, it talks about how that all works. So I went ahead and reading the manual, I set up profiles for 720 by 400, and I set up another one for 640 by 400. And then I have a Elgato Stream Deck, and I know you can't see it here. And when I push that, what happens is, there we go. Notice here it says 640 by 400. So I can push the buttons on the Stream Deck to switch the input configuration. And that allows me to switch whether I am looking at the graphics mode, like so you run a game, you need to switch to 640 by 400, or I can push this button here, and there we go, now we're at 720 by 400. Now I think what's wrong is the phase is off, and that's why we're getting that shimmering. There we go, no more, well, there's still a little bit of shimmering. Okay, there we go, the phase. Well, I don't know, you know, you start to see those lines in the background, but this has very similar controls to what you see on an LCD monitor, you know, the older style 4x3 ones, where there's the phase and the pixels and stuff, and you can move that stuff around. Anyways, text mode's looking pretty good now. This is the DSLogic card that I was testing with. It's gonna be different probably with this card here. So anyways, we know the capture setup is working good. Sorry, that was a little bit of a tangent. But let's take a look at this ISA video card up close and see what it's all about. All right, so here's the video card. This was given to me the other day, so I have no idea if this thing works or not, but I always find these dual output video cards kind of interesting. And if we take a look here, this is what I was talking about. So we have 15-pin HD15, so this is normal analog VGA output that work with any VGA monitor. Let's try to get it a little clearer, there we go. And then this 9-pin connector is TTL output, as in monochrome, CGA, and EGA compatible. Some of these cards, depending on your configuration there, can output a VGA type resolution, but on TTL. So if you have a multi-sync TTL monitor that can support like 640 by 480, and then it can do it. But generally you switch these around and this will become like a CGA card. And I mean, the nice thing about these is they're multi-function, meaning you can use them with any monitor, but generally you have to find the manual. Hopefully we'll look for those and find those so you can configure them appropriately. But the reason why I don't really like these cards is they're very slow when it comes to VGA. Now the card that we were just using was this DSLogic card here. This is not the fastest card in the world, but it's still a decent card. And I did write 8-bit compatible. That means you can put this in an 8-bit slot, and you can let this part just hang off the edge, and this card still fully works. So that's the nice thing about this. I went ahead and tested all of the various video cards I had at one point, and I figured out which ones were 8-bit compatible and which ones weren't. So that means you could put this into an IBM XT, and it would absolutely work fine, as long as this can clear, you know, whatever chips are on the board. From a speed perspective, there is a lot of variance from one VGA card to another, and some of them, like the Sang Labs ET4000s, those ISA cards are really quick, and there's a big difference in the throughput and performance on the same 8-bit or 16-bit ISA slot from one card to another. Now, even though this card here is a 16-bit card, as you can see, I have a feeling if we run a little bit of benchmarks on this, just in DOS, you know, over VGA, it's gonna be pretty slow. So from a RAM perspective here, how much RAM is this here? So this chip here is a 4256K, so 256K times 4-bit. So 2 of these chips here is 256K, and someone upgraded this thing to a full 512K of memory. Now this card, I think, only has 256K actually. Yep, this is a 256K as well. So 2 of these is 256K. And well, it doesn't have any room for any other chips, at least on this card here, so you don't have any additional RAM. So it's funny, this one actually has more memory on it than the Cirrus Logic. Now the thing about the Cirrus Logic cards here, if we flip it around this way, the GD5401, this is kind of their older, lower end chip here, but I think this is a 2D accelerator, so no 3D acceleration, but 2D. So with the right drivers in Windows, even Windows 3.1, you will get hardware blitter and some other drawing functions, like it can, you know, draw a box on the screen and fill it in, and that's done in hardware instead of having to push those pixels across the bus. So it's a big improvement. This chip, on the other hand, this Oak Technologies chip here, I don't think this thing has any acceleration in it. This thing is just simply emulating a VGA card plus CGA and those other types of cards like that I mentioned. And 1990 on those, and you know, so this card seems to be from around 1990. The date on the BIOS though is 1988. And we can tell here that this is definitely 1993. So this is a newer card, and hence the acceleration that's inside this chip. Before we use this, well, I suppose we could just plug it in and test it. We need to see if we can find the switch settings for this. Obviously, you could do a little bit of experimentation to figure it out. Ultimately, if you have the drivers for cards like this, it's actually helpful as well because there will be software control of these modes and whatnot. And like I said, these are good, like jack of all trades cards that pretty much work with any kind of monitor that you have, all the way from like the very newest stuff with VGA down to like the very oldest IBM CGA monochrome monitor, things like that would work with this card. Let's just quickly run a benchmark on the Cirrus Logic card here and see how fast or slow this card is. All right, and remember, we're gonna be running this on my 386, I think this is a 40 megahertz 386 SX board here. Uh-oh, that's weird. Oh, okay, that's no problem. I think I have it configured for a floppy drive. Yes, I do. Oh, yeah, it's not gonna boot because I don't have a compact flash card in there. It's stuck in my XT IDE. While we're at it here, let's turn off the floppy drive since that's not gonna work. Hey, look how clear it looks without any lines. Very nice. With this motherboard, if you plug the compact flash card into the system while it's on and it tries to write to the NVRAM, it can't, and then it kind of gets corrupted or whatever. So anyways, what we're gonna use is this program called VidSpeed here. And VidSpeed, I find very helpful for benchmarking ISA video cards. So it allows you to run all this stuff. So we're gonna run it with a star for normal RAM. Now what you can do is hit plus for all video modes, and it will actually enumerate all those various SVGA modes if the card supports it, and it will do benchmarks. And you'll notice that some cards are fast in some modes and slow in other modes, but anyways, we're not gonna bother with all that. We're just gonna run 0 and 1, and let's run L. That's 320 by 200 at 256 colors, which is what a game like Doom would run in. So we hit enter on this, and there we go. It says 256K, which is what we knew. And this will give us a good idea of the performance of this card over the ISA bus. Now this particular motherboard allows me to set the ISA bus speed, and some cards, if it supports it, that can really improve the performance of the video card. Now there's what we're getting there. So we're getting pretty bad performance. This is a Cirrus Logic card here, 3.1K per millisecond on 40 column text, and then we're getting 1.8K per second, or K per millisecond at 80 column text, and then the 320 by 200 is 2.4. Now I kind of recall that a good performing VGA card actually gets around 7K per millisecond, even over the ISA bus, like what we're hooked up here on this motherboard, would get better performance. Just for fun, let's go into here and I'm gonna change the bus speed. So we're gonna turn off the auto config, and now it's S clock divided by 40. So that's 40 megahertz divided by 5, which is around 8 megahertz or so, right? So if we change this to 4, it's gonna run the bus around 10 megahertz. So let's just see what that does to performance. Generally, you can push the speeds pretty high. A lot of cards are very tolerant to the faster speeds, and you have to consider that the other cards in here need to be able to handle that faster speed too, like the ROM card here, plus the IDE card I have installed. All right, so we're gonna run the same test again, 0, 1, and L, and let's just see what we're getting now. Now, fortunately, I did not save the actual, oh, I can tell it's a lot faster. I think it's a lot faster. I didn't save the original results. We'll just go with these 10 megahertz results here. All right, yeah, it's definitely a little bit faster now. So almost 4K per second, 40 by 25, 2.7K per millisecond, sorry, at 320 by 240 or 200, and then 2K per millisecond at 80 by 25. I've never really seen many cards that are quite a bit slower for 80 column text than 40 column text. It's almost half the speed. So that's pretty sad, to be honest. Either way, what I did is I grabbed a screen capture of the results there, and let's swap over to this other card here, and let's see the performance of this card. Now, I'm just connecting this thing up without even looking at the jumpers, or switch settings, that is. And sometimes there's a setting for like 0 wait states. This card doesn't seem to have any obvious jumpers, but sometimes you have a 0 wait state jumper, which can, speed it up if it's set for 1 wait state. Let's see if this card even gives us a picture at all. Ah, it's working. Okay, look at that. Multi-frequency monitor, 512K. One thing I'm noticing is that the text seems brighter. So the rendering of the text is definitely brighter on this card than on the other one. Let's just see what that looks like in a program. Yeah, it's almost blown out a little bit. You have to remember that when this card was made, like in 1990, you weren't using LCDs or anything with a digitizer. It was always going to an analog monitor. And in that case, you could just control the brightness and contrast knobs to set it up. And once you plugged it in, it was set like that. This DSLogic card, I would say, is normal with its video level output, but I guess this card is outputting hotter RGB analog signals than that one, which is causing it to look a little brighter. Now, in my Extron, I could turn down the brightness. I mean, look, yeah, actually, see how open and the S, they're not even visible? Let's just see if I can fix this actually in here. Let's go to the menu. This will be in picture controls, if I recall. Brightness and contrast, yes, okay. So we hit enter here, and if we turn this down. Now the thing is, I found that setting I was at, which I already forgot what it was, is a bit more appropriate for normal VGA cards, but obviously this one is a bit brighter, and therefore, like, I turned it down and now it's visible. That's all part of the problem with digitizers, digitizing analog signal. You're gonna get some clipping, which is what we were just seeing there. Either way, picture looks good otherwise though, doesn't it? And this card's obviously running properly at 10 megahertz. So let's run vid speed again. So obviously this star just tells us what the memory access speed is. That doesn't really change from one card to another. And we are gonna run L, and let's see how fast this thing is. Now notice it says 512K, or it said 256K here. This card might be faster. This might be faster than the DSLogic card. I don't know, we'll see in a second. So I don't think this thing can detect the difference. Wow, all right, well, a few things that are different. This card is running at 70.11 hertz. The other card was running at 69.76 hertz. It's neither here nor there, just is a slight difference. Okay, 320 by 200, 2,722 bytes per second. And the old card, or the DSLogic card that is, was 2,699. So it's faster than this card, just barely faster. 80 column text on the other card was 2068 on the DSLogic here. So this card is actually faster. And then 40 column text though is about the same speed, and that is actually slower. This was 3,792 bytes per millisecond. Now I'm looking around for a faster video card than this, and I thought I usually keep one over there in the pile, something like a Tseng Labs card, and I can't find one immediately. Let me just go quickly take a look. Yeah, okay, I wasn't able to quickly find one of the cards. I have like a PCI card over there, a local bus card over there. I have a couple selections. I guess I put away my fast cards, or I might have used one and put it in a system. Just trust me that there is a big difference, and I'm pretty sure even on this 36SX motherboard that I can get more like 5,000 or 6,000 characters or bytes per millisecond with a faster video card. And that really does make a big difference. If you think about a game trying to update the screen and do it at 60 frames per second or 30 frames per second, if a fast card's able to push twice as many pixels or 2.5 times as many pixels, that really makes a big difference. Okay, so I think what I want to do next is, we know this card appears to be working. We need to run probably like a game on there just to make sure it's good. I want to pop this into this 8-bit slot right here, and let's see if that works. Now, there are a couple jumpers on here, and it's possible one of these sets up this card for 8-bit mode, and it's possible one of these is for 0 wait states. But let's just pop it in this slot here, and let's just see if it works without having to change anything. Power this on. Oh, look at that, it just works. Well, that's sweet. I can tell you one thing, it's probably gonna be slower. We're still running at 10 megahertz on the ISA bus, but we go to vid speed, 01L. Let's just quickly see how much worse the performance is. I'm gonna predict it's probably gonna be about half the speed, but let's see. Yeah, there we go, about 1326. Now recall we were getting almost 3,000 or so, so I think it's just about exactly half the speed running in an 8-bit slot. Now in something like an XT, that doesn't matter. The processor is so slow, and that bus is also running at 4.77 megahertz, it's barely going to be able to push any kind of pixels or data across the bus. So I wouldn't be surprised on an XT, you're only going to get like 700 bytes per millisecond, and that's about as fast as it can possibly go with the CPU. But it is really cool that this card does just work without changing anything in an 8-bit slot. All right, so now I want to see if I can figure out the dip switches here. So this post on VCF here is talking about a combo EGA VGA card, which is clearly what we're dealing with here, but that's not the same card. It just looks different. The main chip is different. It's a different RAM configuration. I wouldn't be surprised if it's 256K. Yeah, these are 64K chips, but I wouldn't be surprised if the dip switches are similar. Let's see what people link to here. Oak Technologies, the layout of this card is similar to ours. The RAM is different though, so it's similar but different. Let's see what we got here. How many switches do we have? Okay, so 4. Okay, it only has 4 switches. And this card here has 6 switches. Could be that the first 4 match this other card we're looking at here online and the other 2 don't do anything, but I'm gonna keep looking to see what I can find. I'm over on the RetroWeb because RetroWeb's been adding tons of cards to their database as well, so it's not just motherboards and stuff. And look, here's an OTI VGA, and this thing does just say OTI VGA on the BIOS chip right here, and yet, this is not the card, obviously. This is missing the analog. I mean, it says OTI VGA. Sticker's very similar, BIOS 2 of 2, odd. I mean, it literally, sticker looks exactly the same. Now, I think one of the things that happened with these cards is they removed the digital section because people just didn't need it anymore. And I think the switches are generally only for the digital section, whether you have a CGA or EGA monitor, things like that. VGA is just VGA all the time. It does seem to have the same amount of memory though, 512K. So it's possible the main chip is the same. This card here is an OTI 067. And look at that, OTI 067. Same chip on both of these cards. Okay, well that's a start. I mean, not really, but yeah. This thing has 2 jumpers down here, while this, the jumper block down at the bottom, has 2 different positions, so could be similar, I don't know. No documentation available though for this card, unfortunately. Really nothing available for it. I notice here it thinks this card is 1 meg. Let's just try to validate that ourselves. No. It's not 1 megabyte. 2 of these chips is 256K. This is a 512K card. So that's not exactly right. Okay, well, OTI doesn't even have the chip here, so I can't search by that. Wanted, the BIOS for the VG7000. Here you go. So here's a picture. This is not exactly our card, because this has the feature connector right here. But it's the OTI 067 chip. It does have dual connectors, but only has 4 dip switches. But notice, looks like the footprint can accept 6, which makes me think that the other 2 don't do anything. But you know what? Take a look here. We can see that 5 of the switches are wired up and the top one doesn't appear to be, unless, you know, it's on the top side here, which it could well be, because I see a trace there as well. I do see right down at the bottom, VG7000. I think that's what that post was about, but this says Rev B. I think whether it has the feature connector or not, I wonder actually, now I think about it, maybe those switches are something to do with the feature connector. But what we do have is a link to a manual. Let's see if this link is working. Now this is one of the issues, I didn't realize I'd get so stuck on this card here. This is one of the issues with these VGA type cards, is there are so many variants of them, and really the manuals, oh, this was made by DFI, this particular variant at least. Ah, look, this seems to have more switches on it as well. Excellent, excellent. So more jumpers than this card has. I notice this one here says NI or I. Non-interlaced or interlaced. I bet you that's what that is. So 800 by 600 and 1024 by 768. You could run those in interlaced modes if your monitor didn't support non-interlaced. This one just says JP3 on it. No actual writing on it. So I'm assuming this is a hardware configuration for the interlaced mode. And I don't know about this one. Okay, so back to the manual here. 100% hardware compatible with all VGA modes, EGA, CGA, MDA, Hercules, graphics compatibility, TTL, and analog, along with portrait display. Ooh, for that pivoting monitor, right? Interlaced and non-interlaced, up to 512K of RAM, 44256 DRAM, fast host access to video memory, bus auto detect mode, so we already figured that out, 8 and 16-bit, 132 column text, 1024 by 768 with up to 16 colors depending on the memory configuration, analog digital connectors. It says it has a 6-position dip switches with the monitor type selection being the first 4. Is that it? Yep, that's it. So there we go, CGA, MDA, pure MDA, no emulation. That means it won't try to do graphics modes on the monochrome monitor. EGA, pure EGA with no emulation, VGA color, VGA monochrome, so you can force it into that. And then we have 8514, that's an IBM monitor. I can't remember what the deal is. Is that the professional graphics adapter monitor, maybe? I don't know, maybe there were some slightly custom modes on there. And all these NEC monitors here, these are actual multi-sync monitors, which do support all sorts of different resolutions, higher than regular VGA. And there's some notes here that off is open and on is closed. And switch settings 5 and 6 say reserved, and it doesn't even tell you how to configure them. I guess they are set to, you know, this does not help us. Is the black where the switch setting is, or is the white where the switch setting is? Anyways, look at this. If you select the switch settings for VGA color monitor, the maximum VGA resolution will be limited to 640 by 480, so it won't even do any of the higher resolutions. The board will not be able to make use of the extended high resolution drivers for accessing 800 by 600 and above. The system will hang if you try running a high resolution mode with this switch setting. So looking at the switches down here, it's down, up, down, up, down, down. And according to the legend on here, down is open. And I'm confused because I thought it was on, off, which kind of matches what we have here. But according to VGA color, it's off, on, off, on. And just so you can see what I'm talking about, there's the current settings. Down, up, down, up, down, down. And you can see right there next to the one down, it says on. So the one that matches is this one, NEC XL, some kind of a multi-sync monitor. Let's try switching this to VGA monochrome, on, off, on, because this will be pretty obvious to us if it's working as we think it should. On, off, on. And what I mean by obvious is everything will be black and white. So it will be, yeah, there we go. Everything's in black and white. Okay. Well, so that means that the 2 extra jumpers, 5 and 6, are in a configuration that is unsupported, apparently. Well, what we can do is we can run this in 2, which is the black and white text mode, and there we go, we're getting 27K per millisecond, which is exactly what we're getting in color mode. But we're stuck in the monochrome mode, which is how we have it set. So there's edit, and yeah, it's running in monochrome mode. So I'm just changing the settings to be color VGA, I think. Yep, there we go. Okay, it says it right there, VGA color. I should have realized that. Do you see the banner there, VGA color, and before it said multi-sync. So running this vid speed again, I think we'll just see exactly what we had before. And yep, 320 by 200 color mode definitely is working. And yet performance is pretty much exactly the same. Cool. So one thing we can definitely tell right now is that switch 5 and 6 are in the wrong position when it comes to at least the card described in the manual. It wants to have 5 and 6 in the same position as switch 1. And right now they're in the opposite position. Now I don't know if that's because this card has the feature connector or what, but I am just going to switch these to match what's in the manual there. And I'm just going to power cycle the computer to see if there's any difference. I'm not really predicting that we'll have any noticeable difference. Now it still says VGA color. Everything looks fine. What I'm going to quickly do is enable high mem sys, and let's see what else we're going to do. I need to turn 386 on. Get this out of here. Rem that out. I really need to create myself a nice boot menu for these different motherboard configurations. The reason why I'm enabling the memory manager is I want to run Doom on here, just see if this card is working properly, at least in Doom. All right, there we go. EMS is running. All right, EMM36 is running along with high mem sys. Let's just run for fast Doom. I'm just going to set this up with no sound. Select controller, keyboard only, save and launch. Okay, there it is. Now, see how there's a little bit of lines and stuff? I need to switch modes. Uh-oh. Demo is from a different game version. Oh yeah, you know what? I copied the wrong WAD files in there, I think. Let's just try that. The game runs if I go into the game really quickly, but if it tries to start one of the demos, it doesn't work. I need to find the right WAD files. Let's see if I can do this quickly. New game, come on, go, 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 go. There we go. Let's switch modes here. There we go, 640 by 480. Now, oddly enough, the brightness is brighter now, and that's because this profile has that brightness turned up. But there it is. Hey, you know, performance, not too terrible. This is a 40 megahertz 36SX here. Are we running in low resolution? Yeah, we're running in low resolution mode, and we're getting 17 frames per second. I don't have a mouse hooked up. This is not really configured correctly for me to play. I'm used to playing with a mouse and WASD, and this is not configured for any of that. But hey, performance is not terrible. Detail level is low. If we put that on high, it's really gonna slow down. It's really gonna slow down. Invisible rendering, flat? I don't remember which one gives the best performance here. CPU renderer, Intel 386SX, 4 frames per second. You know, I bet you there's people that played at this performance back in the day. I am sure of that. I mean, you might have shrunk your window down a little bit. Does this speed up the frames per second? Yeah, look at that, 9. Nice. No, 15, actually. Anyways, I'd say that this card is working perfectly, which is what we really wanted to test here. Ah, that's all blown out now. Let's switch back to 720. It's a bit better. What we need to do now is test this card in CGA and EGA mode and stuff like that, and we can use the RGB to HDMI. So switch over to the RGB to HDMI. It's letting us pick the profile here, and yeah, I notice there's OTI VGA. Now, I haven't changed any of the switch settings whatsoever. I'm curious if this card hooked up through the digital connection is going to output 640 by 480 at 70 hertz or 720 or whatever, and the RGB HDMI is actually going to work. Yeah, look at that, it freaking works. So what we're looking at here is VGA timing for 640 by 480 and 720 by 400 at 70 hertz. So the timing is VGA, but we're viewing it over TTL video. So not analog RGB, but just those same 16 colors here that CGA supports. That's it. Now it looks like there's a slight shimmer going on, and that's probably just this thing. Let's do auto config here. See if that can fix this up a little bit. And then what I can do is I'll just shift this over slightly in the geometry setting mode. So we can go in here and do H offset and get this into the right position. There we go. So it looks nearly perfect. There's a little bit of shimmering happening on the edge here. I don't know what's going on there, but you know, without having to tweak all the settings and stuff, you know, I can't tell exactly. Now this is just so funny because yeah, like I said, TTL video, but VGA timing. Now if you had a multi-sync monitor, like a TTL monitor that supported multi-sync, it probably would display this mode correctly. Now, the funny thing is, VGA supports all sorts of features it can't do over TTL, like selectable color palettes. We're stuck here with the standard TTL colors. So that means if we run fast Doom here, the game should work, but we're gonna have completely screwed up colors because the game's gonna think we're running in 256 color mode with, you know, adjustable color palettes, and yeah, that doesn't work. There's a whole lot of shimmering going on there. Now, the funny thing is, it's a lot of shimmer going on here, but it's actually running at 640 by 400, I think, instead of 320. And let's change the sub profile here to one of the other modes, VGA text. So it doesn't have a sub profile mode for the right thing we're in here. So we got CGA, yeah, VGA text, okay. What's happening is the geometry is set up for 720 by 400, and that's why we got so much shimmering here. The profiles on the RGB HDMI aren't set up for this 640 mode that we're in right now. Now I could try to fix it. Let's see if I can do that. Okay, well, I think I have it set up here. It's not perfect. It's still a slight shimmering going on, but you know, there's a bunch of settings to tweak. But as you can see here, it's working a lot better in this, well, graphics mode here. Now, it's curious to see that 320 by 200 pixels actually is rendering, at least the way the output is coming out of the digital connector here, in a 640 resolution. You can see those lines there. Now, maybe this has something to do with the way the DAC looks up the color palettes, like that's the information, like Luma code almost, for it to look up the right pixel or something. I'm not 100% sure. But yeah, pretty curious. So that's what it looks like to look at an analog signal through the RGB to HDMI through a card that does output the same resolution, the VGA timing, with TTL video. This is what we're looking at here. Pretty neat, huh? It's kind of nifty, but it works. It just isn't particularly usable here. But as soon as we exit out of here, I think one of the problems is it's now in the wrong mode. I really should save the mode that was in there and then create a profile, separate profile for the graphics mode versus the text mode. That's just like I was doing with the Extron between the two modes. You got to do the same thing with the RGB to HDMI. So of course that means now is what we need to do is let's just try switching this card. I'm going to do EGA attach and I'm going to not select the one that's no emulation. So we're looking for off, off, on, on. And when we turn on the machine now, I am pretty sure we are running in an EGA mode now. And let's check the menu here. Yep, EGA mode 2. So the timing that's coming out of this thing is absolutely just normal EGA. Now, the fact the cursor was messed up there has nothing to do with the card. That has to do with the Xansi driver I'm using on here. It's not really designed for these older types of cards. So this would completely work on a standard EGA monitor. Now let's try running vid speed here with 0, 1, and L. L was 320 by 200 or 256 colors, and let's just see what we get performance-wise here. All right, so performance in EGA mode here seems just about as good as it was in VGA mode. That's a lot better than if you use an actual EGA card. EGA cards are 8-bit, first off, and second of all, they're just really slow. That is really decent. Now, we couldn't run the PS2 mode there, MCGA, right? Because this thing doesn't support that. Let's run it with a plus, which is going to run all the modes it can, but notice it says it's an EGA 128K high-res monitor. Let's just see what we get out of this thing. I think that's CGA mode right there. And if we look at the menu here, yep, CGA 40. That's kind of weird though. It's looking a little stuck. Mode CO80. Nope. I think it's frozen. I think the auto detect routines aren't super great. I can hit Control-Delete. They aren't super great with that vid speed utility. Oops, let's exit out of this. Well, I think I need to eat my words. When originally at the beginning of this video, I said that these types of cards are pretty bad VGA cards and they're just not really great for EGA or CGA, but I take back what I said because this seems pretty fast in CGA and EGA mode. So there's Fast Doom EGA. Let's see how this runs. Of course, the colors are going to suck because it's just stuck with the 16 color. But on the other hand, let's see if this is pretty good. I got to get out of the demo really quick here. Okay. Well, performance sucks. I don't know why there's no frame per second counter. Is that 8.5? Weren't we getting like 15 in VGA mode in this exact resolution and everything? Okay, 11. I mean, it's slow, but it's not terrible. So 8 to 11. What I need to do is, I think I have an EGA card over there. I need to grab it and we'll compare. Here's my EGA card I just happen to have sitting there. It's an EGA 3000, whatever that is. Now all actual EGA cards are only 8-bit. That means that if you're using them in a 286, for instance, you're leaving quite a bit of performance on the table. This is in the wrong mode here. Okay, here's vid speed with the 8-bit card here. Let's see how it performs. Anyways, as I was saying, if you put this in a 286, you're leaving performance on the table. Yeah, 500 bytes per millisecond. Let's, well, first we'll run fast doom, and then we'll go back to the other card. And we'll put the other card in the 8-bit slot. Fast doom EGA. All right, here it is. Is the performance worse? Yeah, maybe not. Okay, I said it was leaving stuff on the table, but does this really seem slower? You let me know, what do you think? I'd say yes. We were getting like, well, I don't know, the frame per second counter doesn't really seem to indicate that it's any slower, but it seems slower. I should just run the benchmark. Wouldn't that be a little bit more scientific at what we're looking at here? But I think the benchmarks don't work, and that's because of the WAD file. I'm using the wrong file. Well, I'm not 100% sure, how much performance we're actually leaving on the table. We must be leaving some on the table just because you're stuck with 8-bit. What we'll do is we'll put the OTI card in here into the 8-bit slot in EGA mode, and we'll just try to see if we're also getting the bad performance. So vidspeed 0.1, we were getting 504 for 8-bit EGA using this card here. What are we gonna get now? Okay, yeah, look at that. More than twice the speed. So even in an 8-bit slot, so in an XT, I don't know what you'd be getting in an XT, but more than twice the speed of this card. And this card really does run at the same speed as a normal EGA card from IBM, one of the original IBM cards. So this OTI card, I'm being proven wrong here. Performance in VGA mode is not top-notch, but it's definitely faster in EGA mode than a regular 8-bit EGA card, even in an 8-bit slot, so even in an XT. So I'm just gonna switch this card into CGA mode, so all down switches. And there we go, good old CGA. Let's see what the performance is, and I moved it back into the 16-bit slot here. Let's see what we get performance-wise in CGA mode. And I bet you it's gonna be a lot more than we would get with a regular CGA card. Wow, we're getting really good performance. We're getting as fast performance in text mode as we were in VGA mode. And that is absolutely shocking to me. It also thinks that it's got an EGA card in here. And I'm assuming we are going to get the 16 color 320 by 200 modes. Like Fast Doom EGA, I think actually might work because it's not using the high res EGA mode, it's just using the low res mode. And let's see here. And we were getting faster bytes per second, bytes per millisecond in CGA mode than we were in EGA mode for whatever reason. Uh-oh, yeah, so it did not initialize here. Oh, it did. Right, so it did not initialize any kind of graphics mode, and we got that same error, so that's interesting. Now this mode right here we're running in would absolutely work perfectly if you hook this up to a regular CGA monitor. Like, it's completely supported by that monitor and it would work. We're using the RGB to HDMI here. But what I wanted to do is run the various graphics modes here. Uh-oh. Oh, what happened? This happens occasionally. I'm gonna reboot the RGB to HDMI. I rebooted the RGB to HDMI. And okay, there we go. Okay, there we go. So we're getting some kind of CGA mode here, but it should be showing like a test pattern, not this. So this card, I don't think it has very good CGA compatibility. And I'm just getting beeping coming from the computer right now, which I guess means it's frozen. That's not reassuring. Let's go into here and change this to CGA. I don't think that'll work, but let's see what happens. That's interesting. You see that? We're getting like what looks like snow. No, display mismatch. Okay, so even though it's in a CGA type mode, it wants to be in this VGA setting there. It does say monitor type CGA at the top there. All right, what I'm gonna do is I'm gonna run CGA compatibility suite and see if we can get any graphics modes working on this. Did you see how slow that was? That's interesting how like That update speed seems terribly slow. A lot slower than the benchmark would give us the impression it was actually running at. So I don't think any of these compatibility modes are going to work at all. I think this thing is going to be completely not compatible. Oh, that works? I'm shocked. So that is actually a CGA like 6845 reprogramming thing, and that actually works. I can't even believe it. This is not going to work. No, that didn't work. Let's see about this one. No, the graphics modes don't work at all. And they just freeze the computer too. I wonder if there's a fault on this card. I can hit Control-Delete. I mean, it's pretty sad, to be honest, if this card emulates CGA here, but it can't do any of the graphics modes. Let's try composite color bar mode, which does use a graphics mode. Nope, and that's not working either. So none of the CGA graphics modes appear to work on this card. I keep going into the BIOS by mistake there. All right, let's try Attack of the Petsky Robots. We'll run this in CGA 4-color mode, and we'll see if we get, nope, no video. So the weird thing is I'm pretty sure in EGA mode this would work. Let's just swap this over real quick. So we just switched the first 2 switches to the off position. Now we're running in EGA mode. This has emulation, whatever that means. And now if we pick CGA 4-color mode, that's 3, this probably works. Okay, it does not work. Maybe there's a fault on this card. This has got to be a problem. There's no way that this wouldn't normally work. I have a thought. Let's change the bus speed back to 8 megahertz, because maybe we have an issue there. I'll put this in auto mode. Auto mode does do that calculation automatically, and we'll set it to the 8 megahertz. Perhaps there's some kind of a speed issue happening here. If we run Petsky Robots in EGA mode, I think this should work. Yep, there we go, looks good. But and now let's run it in CGA mode, and it does not work. Yep, gotta be a fault. There's gotta be a fault on this card. There's no reason why these modes wouldn't be working here. What I do want to do is let's just check to see if there's any other modes here. VGA, pure EGA, okay, I don't know. Let's see if there's anything about the jumpers here. Jumper mode, interlaced or non-interlaced. Okay, we already know that. All right, so this card has JP3, right, which is the enable interrupt or disable. I don't think, nothing really uses IRQ2, so usually default disable is the correct setting. And let's see what this thing is currently set to. I don't think that's gonna be the problem we're having now with CGA not working. Now, according to this, it's set on 2 and 3. Now, 2 and 3 is actually this position. It looks like the numbers are reversed. It's 1, 2, 3. So I'm assuming the interrupt is disabled. But CGA mode does not use the interrupt, and definitely this card seems to work fine except for that mode. Oh, there is a third jumper on here, actually. It's labeled JP1, which is non-interlaced or interlaced, but that's labeled JP2 on this card, and JP2 is the one that says interlaced, non-interlaced. Either way, it looks like you can force 8-bit operation or leave it in 16-bit operation, which I assume that this jumper does, or could be either one of these that does that, to be honest. I'm not totally sure. My assumption is this jumper with the interrupt, since it's right close to the bus connector, is the bottom one here is actually what goes to IRQ2. And I can confirm that because that's the jumper block there. Notice it goes right to that pin there. So that means that, yeah, the center pin on the jumper block goes there. So in one of the positions, that doesn't do anything, and in the other one, it does. So that's the jumper that I'm talking about right there. I'm assuming it's disabled right now. And then up here, there's this jumper, which I forgot to even mention, and then the interlaced, non-interlaced. Notice the text here. Jumper JP2 is only active when it's operating in modes 55, 56, 57. Clearly that's talking about interlaced, non-interlaced, and it says JP2, and yet up here, JP1. Yeah, there were a lot of variants of this card, obviously, and I guess they sort of switched those things around, depending on which card it was. Now, the manual here has more pages that it is not covered. They just scanned the relevant ones, because I noticed here on the last one it says, you know, it's talking about installing the card, and yeah, there's obviously more pages after that, but that's fine. All that was really relevant is the switches we have here. I'm sure the rest of the stuff that's in the manual wasn't important anyways. I guess just for fun, let's just alter these jumpers on here. Let's just see if that somehow makes some kind of magical difference. I'm sure it's not going to, but you never know. Anything is possible. It's possible I just forced it into 8-bit mode. I guess we can tell that by using vid speed real quick. That's kind of interesting. That actually sped it up. I wonder if this was somehow stuck in 8-bit mode or something. We'll go to robots. We'll run 300. Nope. Last but not least, let's go back to VGA mode here. And I want to see if the CGA thing is actually working here while I run this in VGA mode. So we'll go back to the Xtron, turn this on. Here we go, VGA color. Yes, 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 yes. Do we have functional CGA emulation in VGA mode? This should obviously work. If this doesn't work, wow, this does not work. We're getting just a black screen here. Just for grins, I'm gonna set this back into the multi-sync mode that this thing came in, multi-frequency. Let's see if that makes a difference. Let's just run vid speed really quickly, see if there's any difference in performance here. I don't remember how I left the jumpers here. No, I think that's about right for 8 megahertz mode for the bus. All right, so let's just try VGA mode first, make sure that works. Okay, yeah, it looks good. And we'll try EGA mode, make sure that works. That works fine. And now we do CGA mode, and that does not work. All right, well, I don't know if what else there is to do. All that testing, and CGA mode does not work on this card. Now, you may have noticed there's a big dent in this crystal oscillator here, but there's no way this card would work properly in the other modes if it was that crystal that was causing this issue. In fact, CGA and EGA 320 by 200 share the same exact output timing on the digital connector here. Now in EGA mode, it emulates it in an EGA, in VGA, so that's 640 by 400 at 70 hertz in both of those modes. So the fact that this can't run any CGA modes doesn't really make sense. I mean, I suppose it's possible that there's a problem with video memory. I'm just gonna, I guess, pop these two chips out here. Let's see if somehow that makes a difference. I don't know. You know, CGA only needs, I think, 16K of RAM. You definitely don't need all 512K this card has on it. So now it just got 256K and these chips are soldered. I really would be skeptical if there's an issue with the RAM on this that's only affecting just the EGA mode. It really screams that there's just a fault with the main OTI chip on this card causing these issues. So it does say 256K, so it definitely detected that the RAM's been removed, so that's cool. No jumpers or anything needed. So if you have one of these cards and it is working, just populate that RAM. You need 44 256 chips, pretty easy to find. All right, so we'll start with EGA mode. That was number 2. I'm sure this is gonna work fine. Yes, it is. It's a little blown out, but that's just the capture device here. And we'll do 3 for CGA. No. And it's funny, it made a little chirp out of the speaker, and now we have a black screen. So my assumption is, oh, it rebooted itself. So removing the chips here made no difference. Just to kind of show that this does work properly, we're gonna go back to the DSLogic card here, and you will see that everything will work fine in Petsky robots and everything else. And it's just very interesting. It's interesting how when you have it in digital mode, this OTI card, it does go into CGA, just the colors were there, but it's still not rendering properly. So there we go. There it is. CGA works perfectly. No issues whatsoever. And that's with the DSLogic card. So that's a bummer. This card is actually cooler than I thought. Now I'm pretty sure I have some more of these around. I just never really tested them. I always assume that these are slow. I've tested some of these dual cards before made by ATI. They're ATI All-in Wonder. In fact, I'm pretty sure in my 286 I have one of those. But for sure, that card is a really bad performer VGA card. And then when you put it into CGA or EGA mode, it's even slower. And I don't feel it's any faster in the old TTL modes than even the original, like, you know, 8-bit EGA card. Like, it doesn't really give you any performance benefit. But this OTI card does seem to give you performance benefits in the digital modes. So if you're running a 16-bit machine, like the 286, the IBM back there, and you have an EGA or CGA monitor, I think there's performance to be gained by using one of these cards with the old monitor. If, of course, the CGA mode is working, because without that, that's kind of useless. What's cool is you did also see in Jim Leonard's CGA compatibility suite that in CGA mode, the row reprogramming works. And there are games like Pacu, I think one of them is like a Pac-Man clone, that uses that pseudo low res, high color graphics mode that CGA does that you need to have the row reprogramming to work, and that does run on this card. So if this card were working, I think that would be a pretty cool card to use. Now, I don't think there's any like way for me to try to repair this thing. It's not going to be any of these other like chips that are causing the issues. I suppose it could still somehow be the RAM, but I mean, come on, 320 by 240 was working great. All the other graphics modes work perfectly. Just CGA, which barely uses any memory, that's not working. Doesn't really make sense. I don't think it's these the buffers here, because obviously the rest of the card's working. This is the RAM DAC, has nothing to do with the TTL mode at all. That's for the analog VGA. And there's just a few other components on here. So it seems like the OTI chip is at fault here, unless there's a BIOS problem. But I mean, there's stickers on here. I just find that highly unlikely that everything works perfectly except for CGA emulation. So I think for now, I'm just gonna use my marker here. I'm just gonna draw an X on the back here, and I'm just gonna write CGA bad on the back here, so I just remember that that's the fault with this thing. This extra RAM, I'm just gonna stick this on the side here because that might be useful in something else. And unless you've ever seen this particular problem with CGA mode on these OTI cards, or have any kind of thoughts on what might be wrong, I don't think there's much else I can do with this thing. So I think what I need to do now is, this video is super duper long. Let's just quickly test those other two motherboards. Hopefully they just work, because I didn't want to turn this into like a 3-hour video here. I didn't think I would get so stuck on testing that particular video card, but it was a cool card and I really dig it. So, so for now, we're just gonna use the DSLogic card. I'll just pop all the cards out of my motherboard here, the 36SX, and we'll swap over to these other two motherboards down here and see if they work. Now, really quick, this one here is 386DX motherboard. It has an onboard AMD processor here. It does support 40 megahertz, as you can see. It does support a regular 386 and a math coprocessor. Now, one of the issues is, of course, you can't put this in while that's installed. I'd have to desolder this entirely to get that tested. Also notice it's got a footprint for a surface mount math coprocessor. I suppose AMD, when they were making this, they were making these. The difference between this and this is literally just the package. There's no difference in like bus width or anything else. But these 40 megahertz chips were somewhat late in the game. This thing has cache memory on it, so that's pretty cool. 1993 is the date, so it's kind of late for 386s. I'm assuming this is like the tag memory or whatever. You could put another chip here, and then you can have more cache memory. As far as the manufacturer of this thing, 3DIAD-1.1. What do we got here? Cache memory selection. All right, so it actually supports up to 256K of cache. My assumption is that's on here right now is actually 128K. So I think 2 of these chips is 64 kilobytes, and you need 4 because it's a 32-bit system. I think these are 8-bit wide. Yeah, these are 8-bit each. So we have 128K. Plus, I guess, the tag memory. So I guess we're dealing with 8K or something. I don't know, not 100% clear to me. I bet people watching this will probably know better. Now, this motherboard did have a battery on it. It's right here. I ended up removing it. It was starting to leak. You can see there's a little bit of crust starting on there, but really minimal, which is amazing because 386 boards like this are so often destroyed. Now, one thing I'm noticing here, and that sucks, is whoever removed the memory from this, because I was given this board, just ripped it off entirely. So even though these are the metal clips, there was no Fs given when the RAM was removed. So it looks like these are all damaged. Oh, what a pain. What a freaking pain. Chipset wise, we have an ALI chipset. We don't have any onboard peripherals on here, so you have to use cards for everything. No battery leakage, but damaged SIM slots. That is just frustrating. As I said, these boards, the video card as well, they were just given to me. They were all untested. I got this RAM with it as well, so I'm assuming that the RAM was on here originally and was just sort of yanked off. Let's see if this can even hold this stuff in. I mean, held that module in. You need to have 4 modules at a minimum on here. Hey, you know what? They might be damaged, but they are still holding the memory okay. Okay, that's cool. That's probably gonna work. This one here is not really in the right position, but I think it's better than nothing. All right, power's connected. Let's get this post analyzer card installed in here. I'm just gonna leave everything else unplugged right now. Let's turn this on, see what happens. Hey, it's posting. Let's hook up the speaker here. I should have done that already. Let's power cycle this again. Right. Okay, it's just complained about no video card. So we'll just pop in these various cards here. All right, we'll power this up. Yes, it's working, it's working, it's working. All right, what do we got in here? So obviously there's no battery, so it's lost everything. No problem. This looks very similar to the BIOS on the 36SX board we were just using. Internal and external cache. So there is no internal cache on these chips. But the reason why I think that's there is if you had a 46 SLC type chip or DLC or whatever it is, it's a 386DX type chip, but it's got a core that has 46 like features. Cyrix made it, TI made them, IBM I think. Those have internal cache memory, a little bit of cache, and it's L1, so it's nice and fast as well. So I think this option allows you to turn that on. Right now I can't do anything with this, like up, page down does nothing. I can turn the external cache off and on, but the external cache is not nearly as fast as the internal cache on the chips that have it. Looks like you can turn on Shadow RAM, which copies the ROM from your video card into the fast memory on the motherboard. And you can do either the main BIOS or the VGA card or both. F plus C is gonna be both. So we'll leave that on. That's a good performance improvement for 386s here. 3D IAD 2.2 versus the 1.1, which was written on the motherboard. It is not compatible with my ISA card here. I've run into this particular problem before. So see how it's got some garbage there for the compact flash card? I've run into this before with this particular card on some motherboards, and I don't know what the deal is with it. We may have to go back to my 8-bit ISA card here. This is a lot slower, but I think it works. Yeah, it has some garbage there. I'm pretty sure this has to do, I don't know, either incompatibility with my card here, or it's this ISA card entirely. It could be this. And ideally, I should find another IDE 16-bit card and set that up. But it's weird because that card works on most systems, but I've certainly run into some issues. Okay, so I don't need the ROM card anymore because the XT IDE has a built-in ROM. And let's see if this works now. So RAM works, that's cool. And yeah, look at that. That sees no disk card there without any issues. So very nice. This motherboard was left for dead and the RAM was just ripped out of it very, very rudely. And yet, it's a survivor. It's a freaking survivor. If anyone is curious how much faster this video card, the DSLogic card is, hooked up to an actual DX40, 360DX40, let's just run this again. I noticed there was no configuration options in the BIOS for setting up the bus speed for ISA, so I guess it runs around 8 megahertz on here, and there's nothing you can do with it. To change the actual speed of the CPU on this, you do need to change the crystal oscillator. There's an 80 megahertz crystal here, which is very much like the 36SX board that I was testing that's on the floor right now. And I could swap that out. Oh, look at the performance. It's horrible. I wonder if we reboot this. Well, what I want to do first is if we run Doom on this thing, I think it's going to have worse performance than on the 36SX. Just wanted to run speed 600 here, make sure this is running. Maybe we're not in turbo mode. Could be we need a jumper. Okay. Yeah, I think we're out of turbo mode right here, and that's probably why things are terrible right now. Turbo switch. It's these two pins right here. These pins, there we go. Big difference. So you notice the video speed in here matches what's in the vid speed utility. So we hit F9 for retest. Let's see what that does. 1700. Still seems slower than it was on that other machine, but at least the CPU speed is faster now. So we run check CPU. We're just getting a classic 386. There's no way for it to identify that this is an AMD chip. We can run cache check, and let's see how much cache memory this detects. Yep, looks like we have 128K of cache. So you can tell because the microseconds per kilobyte is 40 all the way across, and then it goes up to 97. If this thing had 256K, that column would also have 40 in it. And then if you just let it run through, it says your cache is 128K, 27.7 megs per second, and the effective RAM access speed is 185 nanoseconds, which seems really slow. And sometimes you can tweak this stuff in the BIOS to try to speed that up. But if I recall, oh, we have advanced chipset. I didn't even look in here. Oh, okay, we do have stuff here. All right, auto function on off. We can disable that, and we cannot change this. It was set to 1. Let's just see what that gives us, and we'll leave it set to cacheable there. And what about advanced? Anything in here? Oh, how Shadow RAM changed. I had it set to both. Oh well, went to video. That's interesting. I don't think anything in here will really speed stuff up. I'll try Fastgate 820. I don't remember if that really makes a difference. Yeah, okay, let's see if we have any difference now. Now, it's quite possible we could overclock this thing. You put a faster crystal in here, and this, this chip here is pretty warm. So maybe with some cooling, like a heatsink on there, you could maybe get a little more speed out of this thing, a little overclocking action. Yeah, there's no difference in here whatsoever. Now, it's quite possible this ALI chipset supports more stuff, and they're just, the options are hidden in here. We'll just put this back to enabled. So maybe there's a way to like expose more options, or maybe there's another BIOS that allows you to do more stuff. Look how this has F+C in there again. Interesting. And like I mentioned, if you do need to change the speed of this, you can take this crystal oscillator out of here. I'll just cut this zip tie that's on here. And we'll cut the power on the machine. Pull that out, and then you can just lift this thing right out of there. So this is currently an 80 megahertz one. Let's pop in this, which is a 66 megahertz crystal. So this will run at 33 megahertz now. So if you're trying to run a math code processor, it can be really hard, I think, to find 40 megahertz ones. I happen to have a math code processor sort of sitting on the bench right here. This one I think is 25 or something. So this should boot. Yep, there we go. Oh, and I see it says 33 megahertz right at the top there. Gives us a little hint that this thing really is running at a different speed. So, yep, a bit slower. If anything, the video speed is slightly faster. What happens if we pull this out while it's running? Can we change the speed on the fly? Nope, it froze. Control delete, that doesn't work either. Some motherboards are actually pretty tolerant to that. You could just take the crystal out while it's running and change it, but this one is, no, not so much. It's usually chipset dependent, if it can run at like a 0 megahertz clock or not. Okay, well anyways, this board seems to be working well. Oh, I didn't run the Doom benchmark. Let's just quickly do that and see if that works. Fast Doom, I think, should be potentially slower than we were getting before. One thing that will be slower is the speed of the hard drive here. Loading Doom is going to take a lot longer because the 8-bit card here is nice and slow. It's possible that setting up the caching for the BIOS ROM that's on here, which is like C800, I think, might actually speed up the access time a little bit. Same goes for this little ROM card. If you cache this, you can actually get some better performance. But that's not going to fix the problem I was getting with this card on here. It just seems to be incompatible with certain motherboards. You can see how much slower this is loading. Here, let's quickly get into the game before the demo runs. It's loading. All right. Is this faster? Yes. This definitely seems, oh yeah, 35. Wow, so that 32-bit memory access really makes a difference here. Quite a difference. Spinning around here, nice. Cool. Okay, well, I guess the DX gives you good performance improvement, even though the VGA speed does seem to be slower, and that can be a bit of a bottleneck. We were getting like 2300 or whatever. This is pretty good. Yeah, 24, nice. If we take the jumper off here for the turbo, slows down dramatically. It's a big slowdown. There we go. Put it back on. Looks pretty good. If we put this to full size, what are we gonna get? Probably full size is where the VGA bottleneck comes more into it. Smaller size, transferring less data, probably is more CPU dependent. And now we're stuck with that really slow bus transfer speed. Yeah, for VGA here. Okay, well anyways, working motherboard, awesome. So that means we're gonna give this board a little tick mark here, and it did not suffer any damage from the battery leakage, which was extremely minor. And that's cool, because that's just not super common when it comes to 386 boards. And this is the only thing that kind of sucks. I wonder if I could try to bend these clips back into shape where it hold the memory a little bit better. But you know what? I mean, it's in there. It's in there fine. Cool, one working motherboard. And lastly, we have this, which is a 286 motherboard here, as I mentioned. So we have a 286 here running at 12 megahertz or up to 12 megahertz. Mathco processor, we got some crap on there. Where is the oscillator on here? Chips and technology BIOS. It's really dirty. Battery leakage, none. That was not me. I did not remove the battery. Someone else installed these pins at some point in the past. So whatever computer this came out of, it must have had an external battery connected there. SIPs, these are like SIMs. These are just like 30-pin memory modules. If we grab one of the modules sitting on the table here. So it's just like this. The only difference is it has pins soldered onto every single one of these little contacts. And instead of regular SIM sockets, we got these. Now, what's kind of curious about this motherboard is I don't think I've ever seen 46 or 286 motherboards that had so many banks of memory. So we have 0, 1, 2, and 3. So this motherboard actually has 4 banks of memory. So it has, you know, the equivalent of 8 SIM slots. There's 2 up here. This, there it is up there, banks 2 and 3. So they're interleaved. And the memory that's on here, 256. So this has 512K of memory right now, which is really not a lot. So for 286s, you have to install 2 of these at a time, 16-bit data bus. This thing does support up to 16 megabytes of RAM. So theoretically, if this supported 4 meg SIPs, you could actually fully load this with 16 megs of RAM. I'd be skeptical if it has all the address lines hooked up. See how there's missing pins here? I bet you it doesn't have all the address lines to use more than 1 megabyte SIMs. So probably 8 megs is the most you could run on this machine. Funny is I don't see a crystal oscillator except for this, which is the normal like bus kind of clock one, but it's quite possible that this chipset here actually divides that crystal into whatever the correct amount is to run this at 8 megahertz or something like that. Obviously there's some space here for another crystal. It's quite possible with a jumper configured on here, because we have a couple unpopulated jumpers, that you could select between this and whatever clock divider is happening here. What you can do is look up the part number for this and try to find the data sheet, and then you could maybe figure out, you know, how to repopulate those components to run this at different speeds. Maybe this thing can support up to 20 megahertz or 25 megahertz. I don't know. This is a pretty interesting motherboard though. Mathco processor socket here. That PAL there is in a socket. That's good, I guess. If that PAL's bad, this motherboard is toast. There's no way to use this without that. And there's the keyboard controller there, the 8042. And then, I mean, that's pretty much it for this motherboard. I don't see any damage up here though, which is cool, because that's pretty common for these batteries to leak. This is the backside where the battery would have been, and whoever removed the battery did it before it leaked. This is amusing. Traces that just sort of at an angle there. And okay, whatever design software they used allowed for these different curves. Look at the different angles here. Intriguing. All right, place your bets. Is this motherboard gonna work? It was in a random box of junk. It literally was in a random box of junk. I wish I had taken a picture of it. And it's probably working fine. Here we go, hook up the speaker. Okay, here we go. That's weird. We weren't even getting, there we go. Yeah, it's freaking posting. I think that was just a dirty slot there because it didn't have all the voltage rails and that was not running. It freaking posts. It freaking posts. Amazing. It's so amazing how absolutely resilient this hardware is. It just, yeah, boggles my mind how great it is. Video card in, and we got to plug this in for a little ROM action. There we go. Keyboard's connected. It's still posting. Might help if I had the video connected, although it's kind of frozen here. Ah, look at that. It did post. Let's repower this thing. Okay, checking the RAM. Nice. How do I get into the BIOS? It's the SCAT BIOS. Decompilation or disassembly is prohibited, everyone. I wonder if it's trying to access, no, it's not trying to access the floppy drive, because if it did, this light would be on. I have an LED installed. This is just sitting here doing absolutely nothing. Oh, here we go, real-time clock error. Ah, okay. Maybe I need to hook something up. Control-Alt-S. Control test. There we go. We don't need hard drive. 512K is good. Page up, page down. What's on second page? Numlock. CPU speed. Fast or slow. RAM wait states. Oh, all the way down to 0. We're going to go to 0. You know what? We'll start with 1. We can't do any shadowing stuff because you need to have 1 meg of RAM installed for that. So we can't do that. No EMS is fine. And, oh, we have another page here. Clock source, CPU X 1/4, proc clock 1/4. This is cool. There's lots of stuff to set up here. Dynamic memory sizing. Okay, whoops, I was trying to change this. Let's see what we got here. 1 meg, 1.5, 8 megs. Yes, 10 megs. Wait, what? Oh, hold on a second. This could be using RAM cards that are actually installed in ISA slots. If it said 4x4, then I would think it could support potentially 16 megs by using 4 meg SIMs on here. But I bet you, no system memory board. How's that work? Without having some 4 meg SIPs, I don't think I'll be able to even test this. I'm not sure if that's even a thing without having to make your own. So it lets you set some different stuff. Cool. And looks like we have, oops, one more page here. Chipset, press enter. Ooh, you can control the bits directly in that chipset. So this is where what we could do is look up the data sheet if we could find it, and then you can literally manipulate those bits to do all sorts of different things. The BIOS itself is configuring these bits. All those other options we saw, like on, not that page, but this stuff and this stuff, that's all configured with those bits. But this lets you take direct control of those bits and do whatever you want, but you obviously need the documentation for this to work. So we're gonna hit F10 for save. All right, a little Googling around, I actually found the data sheet for the main chipset here. This chip supports the control logic and clocks for the CPU up to 12.5 megahertz 0 wait states. The real-time clock chip, along with the CMOS RAM, is built in the chipset. DMA controllers, interrupt controllers, all built in. The interval timer and the peripheral interface. Bus controller, clock generation, ready interface. DRAM support up to 8 megabytes, up to 16 with the addition of an external 538 type decoder. It's also a memory controller. It supports shadow RAM, refresh controller, 32 EMS page registers if you want to use EMS, the interface logic to support a coprocessor and the keyboard controller chip, fastgate 820, fast CPU reset, power management, ooh, fancy. Processor clock can be set with internal config registers 46H bits 2 and 3 from the following values. So CPU X, half, quarter, and eighth. Proc clock can be halted to implement power management. Frequency chosen, proc clock must be twice the frequency of the 286. For 8286 with a speed of 12 megahertz, proc clock must be equal to 24 megahertz. Proc clock is derived in one of two ways. From an external crystal oscillator connected to the CPU X, in which CPU X2 is left unconnected, or an external crystal oscillator connected across CPU X1 and CPU X2. Well, this seems to indicate that CPU X1 is the external clock input, and the only crystal we see on this board is like 14 point something megahertz, which would imply to me that you would be running this machine at like 7 megahertz if it's using proc clock equals CPU X1. I must have missed something on the motherboard with another crystal. I don't quite know. Now this data sheet, very comprehensive, really goes into the entire architecture of the 286. They took everything that was on the motherboard from the 286 on the IBM 5170, and they condensed it down into this single chip. It's pretty amazing, to be honest. There were a whole ton of discrete Intel chips, and all the logic and whatnot, it was all just replicated into these single chips here. And that made these small motherboards possible. Here's a whole section on the internal configuration registers. This seems to be something we can configure in the BIOS. It's a bunch of stuff on DMA wait state control, clock control, quick mode. When enabled, ALE is generated for all cycles. Non-channel cycles generate ALE, but no command appears. The channel cycles in this mode do not have any additional wait states. The mode is used on slow systems less than 10 MHz where bus clock is forced to proc clock /2. Quick mode disabled is default. Bus clock select, so that's for the ISA bus itself. Refresh cycle pulse width. I assume this has to do with how much time is wasted refreshing the DRAM. Not sure. 44H peripheral control. Chips video on XD bus. Game port, serial port. So I guess there's a peripheral IO type controller and video and stuff that you can have on the motherboard, and that controls that. 45H, you can non-maskable interrupt disable. There's a bunch of power management stuff, sleep enabled. It's kind of surprising in the 80s. This is from 1989. There was power control for the CPU. You can disable the parity checking for the RAM. Auxiliary parity check is enabled. This generates a non-maskable interrupt, so you can disable that. Guess this allows you to slow down the processor. And there's a sleep frequency. You can really slow down the processor. RAM write protect. You can write protect part of memory. I think this is probably for caching. So you copy the ROM into RAM, into the high RAM, and then you can write protect it. And that's enabled for high-speed RAM caching. RAM is much faster than the ROMs on the motherboard, or the system ROM here, FA all the way through FF into RAM, and then write protect it. Then it acts like ROM, but you get the performance of the RAM. And this is something later 386s did automatically, but this was built into this chipset to give you extra speed. And then take a look at this, DRAM configuration. So banks 0 through 3, which is on the motherboard, and it does seem to indicate here that the maximum memory config is 8 megabytes. Now, these ones with asterisks here, this configuration is implemented using RAS encoded mode, which allows a system to have 8 banks of DRAM. So there are 4 banks here with 2 slots each. It would actually need to have 16 slots because then it would have double the number of banks. So it is saying that the maximum amount of memory that's addressable are 1 megabyte SIPs. It doesn't support 4 meg ones, even though they are technically possible. There's enough address lines there for that. It's not possible here. So the most memory on this motherboard though is 8 megs, which I think is the most I've ever seen on any 286. That's pretty amazing. And then you have 1 meg of low memory that includes the high memory for the shadowing and whatnot. And then you have 7 megs of extended memory. And then this is going into normal IO port stuff. So this is IO port stuff that would be on the normal PCAT just to control various things like turn off refresh and disable the non-maskable interrupt. This has nothing to do with the chipset. IBM 5170 has this as well. All right, so here's the pinout. So input oscillator 1 is the 14.318 megahertz input from an external oscillator or parallel resonance fundamental mode crystal that is tied to oscillator 2. And then we have another input here, CPU X1, CPU clock oscillator is an input to derive processor clock. So we're not using this. It doesn't seem like it's hooked up, but it must be. There must be something happening on the board. Maybe this oscillator 1's being divided or something, or I just missed another oscillator that is on this board. And I think that's it. That's all the signals on this particular chip. Hopefully that's gonna allow this to work without a clock battery installed. This thing may not pass any tests. I might have to just plug something into here. Oh no, it's working. Okay, so it's trying to access the floppy drive there, which is not hooked up. Good, it's seeing the CF card. That is excellent. And let's let this thing boot. It looks like we froze. I'm gonna reboot the computer here. I think I have to hold down shift. It's trying to load EMM386. It's trying to load DOS high. It's trying to do stuff that's just not really possible with only 512K of RAM. But awesome that this motherboard, dirty and everything, is freaking working as well. Super cool. 286 and 386 motherboards are just not that common anymore because they get so damaged from battery leakage. So it's just really awesome that these boards are okay. So we're running in 1 wait state mode right now, 1200, and we're getting 6.8 megahertz. So much for 12 megahertz. Let's put a jumper on here for turbo. We don't need that click, so we'll unplug the speaker here. So we'll put a jumper on turbo here. There we go, 13 megahertz. Now, if we run this thing, I've hit F9. Oh, it's kind of cool. It's actually the CPU clock is changed down to 6 megahertz. So it isn't just adding fake wait states, which is how the 386 board was working. This is actually changing the clock speed. Now the clock speed, yeah, 12 megahertz. So we're running at 13.7 at, I guess that's 1 wait state. And we're getting 1600 characters per millisecond on this card over ISA, so similar to the 386. Let's reboot. And I want to change that to 0 wait state. So it's Control-Alt-S, hit page down, RAM wait states. Now it's funny how CPU speed didn't seem to matter. Without the jumper, it was running at half speed. Let's change this to, I don't know, the RAS delay is. We'll change it to 0. Yep, those are our options. And we'll hit F10. And let's see if this thing can even run. You normally need like at least 80 nanosecond RAM. I didn't look to see how fast this is. Let's see if we get a little performance improvement in Speed 600. Now the IBM 5170 runs at 1 wait state, and that means it's not really that fast. In fact, running at 6 megahertz, you get like in Speed 600 around 6 megahertz, which is where this kind of test originated from. It's a, a crap benchmark. It doesn't really, it's not accurate at all. Yeah, 18 megahertz. So that changing from 0 to 1 or 1 to 0, it gave us a big boost in CPU power for this thing. Now, if we could, you know, put a faster 286 in here, like a 20 megahertz one, and then add a crystal oscillator, and you could really ramp the speed up of this thing. And with all the RAM, up to 8 megabytes on the motherboard here, that's a pretty sweet little 286 board, I gotta say. Pretty sweet. Now, can't really run a lot of games. Maybe Planet X3 works here. Let's see if this works with 512K, so we can't run Doom or anything like that. Yeah, this works good. And that nice performance boost we're getting from having that extra RAM is really good. Now, if we take out the turbo jumper here, well, it didn't really change anything, to be honest. That's interesting. This game is pretty efficient. I guess the fact that it runs on XTs and stuff shows you that you don't need a lot of power for this. But yep, we're getting 18 megahertz equivalent speed. This is a pretty speedy little motherboard. All right, well, there we go. So this little 286 board, let me pop all the cards out of here. This card is working as well. So I figured both these motherboards were working. They were both, you know, even though the SIM slots were kind of ravaged on the other one. And actually, funny thing about this 286 board when I got it is that all of the SIPs had been bent flat. So I don't know, it was just like in a box of junk, and both of these SIPs had just been bent over, so I just bent them back. The 286 chip here, the AMD chip, it's pretty warm. A little heatsink might be good. This obviously needs a wash, but it freaking works. No battery damage. Nice motherboard, compact size. You can put this in a really small little case without any issue. Yeah, this is a cool 286 motherboard, and I'm pretty stoked that it works. All right, so there we go. 2 working motherboards. That is awesome. And unfortunately, the OTI video card mostly works, but it's got the bad CGA. So if you enjoyed me fiddling around with this testing, thumbs up would be appreciated. I really do like this card. Now I'm gonna go in my stash and try to find another one. I won't do it right now, but I'll try to find another one and see if the CGA mode works. I'm sure it does work properly on another one of these cards, and it's just gotta be this chip here. That's the problem. Now, if you have thoughts about me trying to fix this, maybe I could try reflowing the pins or something on here. Let me know. I'm not seeing anything bent or damaged. Maybe something's not hooked up properly. It's possible. Maybe there's a data sheet for this. I don't know. So yeah, if you have thoughts about this, definitely let me know in the comment section. And I guess that's gonna be it. So that was me fiddling around down here in the basement, fooling around with this old stuff. I am feeling so much better. COVID and stuff is finally getting away. You know, it's getting out of my system. I have more energy. I'm able to eat. My GI problems are kind of going away. So yeah, I'm really feeling a lot better, which is really excited. And today's Monday. I'm going to try to get some administrative work done for the channel here, and then really get to making some videos. So that's going to be it for this video. If you liked it, thumbs up, subscribe. Thanks to my patrons. Names are going upside the screen. You know, all the usual YouTube junk. And that's going to be that. So stay healthy, stay safe. I'll see you next time. Bye.